Live from Las Vegas, it's theCUBE, covering Edge 2016. Brought to you by IBM. Now, here are your hosts, Dave Vellante and Stu Miniman.
We're back. This is theCUBE, the worldwide leader in live tech coverage. Check out IBMGo.com. Donna Dillenberger is here, she's IBM fellow, CUBE alum. Donna, fresh off the keynote, great to see you again. Thanks for coming on.
Hi Dave, hi Stu.
So really enjoyed your topic this year. We were just talking off camera, we were talking last year about sort of bringing analytics and transaction systems together to solve some of the big challenges in the world. But today you talked about open source and you talked a lot about blockchain. I want to sort of share that with our audience. Well, I want to start with, you had 10, I think 10, at least 10 anyway, open source projects that IBM is heavily involved in. Talk about the importance of open source to IBM.
Yeah, I mean, so, of those 10 projects, some of them are, Node.js, Open Container, Eclipse, Open Power, Open Mainframe.
Spark.
Spark.
Linux.
Yeah.
OpenStack.
So, everyone has their own expertise. Every company develops a core set of competencies. So for example, IBM, we're really good at like scalability and security. But when we partner that with other people who donate their expertise in analytics, their expertise in Docker containers, I mean that's like the best date, right? You complement each other, you push each other on, right? There's nothing that sharpens minds like other minds, right? And to have other people with such great skills, right? It not only brings IBM people to a better level of technical expertise, but just that collaboration. It really is. We're better together than separate.
Okay, and then you also talked about well, let's talk about blockchain. It started with Bitcoin.
Yeah.
Right? And I remember seeing Warren Buffett on CNBC someday talking about how Bitcoin would fail. And I remember thinking, well, Bitcoin is more than a currency. Maybe the currency will fail, but the technology implications, which I didn't fully understand at the time and don't claim to fully now, but I think IBM was early on in understanding the technology implications of Bitcoin and blockchain. What were they and what led you to Hyperledger?
Yeah, so Bitcoin started in 2009 as a result of the Great Recession, right? There were a bunch of people, they wanted to build this cryptocurrency that would be free of like central governments and banks, right? And to do that, they thought, okay, we can't even rely on computer systems, right? We have to ensure that Bitcoin would be hosted in distributed computer systems that no one owned, right? And that led to the creation of a protocol that could run on distributed computers, and even if one computer fails, then the Bitcoin network would last. If a set of computers get compromised, then the data would also still have integrity. And so that led to the creation of the blockchain protocol, right? So Bitcoin uses the blockchain protocol to use distributed systems to record financial transactions. But now that you have a distributed protocol that could record financial transactions, you could also use that distributed protocol to record the provenance of your food. So for example, if we're interested in buying this food product, we want to make sure that some of us, right, the eggs came from hens that could walk around freely, or that the ingredients weren't mixed with like glue or something, right? I mean, right now we hope that it's not mixed with glue, but now with blockchain, right, you could have these Internet of Things devices, you could have these sensors put in the soil to measure the toxicity of the soil, you could have these IoT devices in shipping containers to measure the freshness of like lettuce, you could have like the IoT devices, put in like the processing plants to measure, how clean it is, and then all that data, it's put on the blockchain. You can't change it, right? So even if you wanted to tamper with it and say, okay, well, this factory isn't as clean as we thought it was, you can't. It measures the level of toxicity. So now there's that level of transparency, right? And that ability to provide that data in a distributed way, so that even like one owner can't compromise it. That actually leads to more trust, right? So, yeah.
some of the characteristics, help us unpack this. So it's immutable, you just mentioned that, I think I heard it's encrypted, it's distributed, so it's got provenance. There's no third party verification required.
Right.
I tweeted one time that it's virtually unhackable, and somebody said everything's unhackable. I said, okay, if more than 50% of the participants, I guess, collaborate to hack it, it could be unhacked, it could be hacked, but if you and I have a transaction, we have to agree that, hey, let's hack our own system. So it's conceptually, virtually unhackable, is it not?
That's the goal, to make it unhackable, right? So, the Bitcoin was the first one, and the Bitcoin development of their use of blockchain has some weaknesses, right? And that's why IBM with other companies came up with a different implementation of the blockchain, the Linux Foundation Hyperledger blockchain. And the Hyperledger blockchain is extremely different from Bitcoin-derived blockchains, right? Bitcoin-derived blockchains uses things like proof of work, right? And there, when data gets committed, all of the computer nodes have to solve a complex math problem. They have to, hash that into a value that starts with like what they call a nonce number, right, to provide some randomness in it. But then this is the weird thing, right? The computer system that first comes up with the solution to that complex math problem and creates that hash value, that's the data source that all the other Bitcoin-derived blockchains has to follow. Right. And that is hackable, right? As proven by the breaches that were in the news. There's somewhere where $60 million got stolen, $3 million got stolen. Hyperledger, does not have that requirement for solving complex math problems and proof of work. We have a set of validators, and it's more, as you said, if we are part of transactions, just Dave and I, then Dave has to validate that, okay, I gave Dave $50, right? And Dave says yes, truly Donna gave $50, but we don't really care what Stu says, right? Stu is not part of this transaction, so why should Stu have any say of whether this data is valid or not? We keep Stu out. Right, so the Hyperledger, blockchain provides that flexibility so that only the participants who are part of the transaction, they are the ones that know whether that data is valid or not.
And you gave an example of IBM supply chain, for some hardware components, 4,000 suppliers. Yeah. And you've implemented this, and you gave a great demo of this blockchain example, this Hyperledger example, to mediate. Well, today you mediate disputes, kind of manually. Yeah. Historically, you've done that.
Yeah. People will call each other up. They're really frustrated. What do you mean you don't see my invoice?
I sent it. Let me send it again. So, on average, it takes 44 days to resolve. So you've implemented the system with things like proof of delivery and proof of payment, et cetera. What has been the business impact to IBM?
Yeah, the goal, the reason why we put this on blockchain is to reduce the dispute, the amount of time it takes to resolve a dispute, which is 44 days. And then when we reduce the amount of time it takes to resolve a dispute, then we don't require that much money, that we have to put on hold in our supply chain. And then it also creates better relationships with our partners and suppliers as well. And that, has been the goal of the IBM global finance blockchain. Yeah.
Donna, so many of the challenges that we're facing in IT these days seem to fit right in your area of expertise. It's all about distributed architectures. So you mentioned that IBM really has strength in scalability and security. So things like cognitive, Tom Rosamilia said, it's going to be in everywhere. Yeah. IoT is from edge to core and all over the place. How is that knowledge of building distributed systems getting spread in IBM and working with your partners and across the industry?
Yeah. So, when all of us started as technical people, right, we started by building a particular component, right? We programmed, or we built a computer board, right? And we had this sense of craftsmanship, right? Because we owned this widget, we owned this, these 20,000 lines of code, right? But it almost goes back to Dave's question about open source. The real power is when we combine all these things, right? So if we just created little sensors on our own, right, and we never had that data, we never looked at that data through analytics, then we couldn't find as much from putting these sensors in soil or putting these sensors in like airplane wheels or like cars, right? But then you combine that with analytics, and then you could find all these patterns. But then you get this problem. Okay, well then how could you trust the data, right? Because the data sent from IoT devices, to some storage system or a laptop, it could get hacked in the middle, right? And that's when we have the blockchain protocol, right? It gets into a blockchain node, right? Other IoT sensors in the soil also sends the same data, right? So we have corroboration, right? And so that now you have the pedigree of the data, and it's combining all these three, right? IoT devices, analytics, pedigree of data provided by blockchain, and then of course all this, can't run in just like one laptop that's in Las Vegas, right? You need like distributed systems to be able to, safeguard the data and provide the power. So it's weird that, it's almost like baking, right? You have all these ingredients, and when you put them all in, you get a great cake, right? So it's really good to put them together.
I'm curious your thoughts about some of the hyperscale players. People like Google, Amazon, Facebook, and Apple. They all build, very distributed architectures, but they're not nearly as open as a company like IBM. Is that a misperception, or could that be a limit to some of our growth of things like IoT are going to require interaction with some of these type of players?
It's almost like. And maybe this is just a statement at this moment in time, but all roads lead to open source, right? I mean, we were talking about like history, right? So I mean, just look back even before blockchain, right? The open source Unix systems, right? You had Solaris, you had like AT&T, right? BSD,
right.
And then you had Linux, and we all knew at the beginning Linux was not as powerful, right, as all these other Unix versions, but Linux came to be the most adopted, right? And one reason is because it's free, but the other reason is because you have this whole community donating code to make Linux, to make sure it scales, to make sure it's secure, to make sure it works with like little phones and large servers, right? That type of density. You start out as a proprietary system, the Googles or whatever companies, but even then, even the Googles, right? They open source their code, other people donate, and it makes it even better, right? I mean, if you really want to make your product better, just open it up to the light of day of open source, right? People are going to read it, they're going to say, that doesn't work. This is a much better way to do it. And so what? We're grown-ups. We take criticism, right? But it'll make it better. And then we'll say, okay, you put an improvement, but that really is really bad. Here's a better way to do it. Because we're always trying to like one up, each other. That's a human thing.
So Donna, it seems like everybody's a software company these days. So I'm thinking about Hyperledger. What types of companies are contributing to the project? What kinds of things are they doing? Where are they coming from? Is it different industries? It's not just the technology industry, obviously. So.
Yeah, that's what really surprised me. I thought, okay, we're going to Hyperledger is going to be an open source blockchain. It's only going to be blockchain companies donating, but that's not true. It's industries that are writing blockchain applications. Financial companies are donating, code to make sure that we satisfy their financial protocol requirements, right? Manufacturing companies are donating code, and to make sure that we support like these manufacturing standards. Healthcare companies, right? So in fact, the fewest numbers of companies that are donating blockchain code are actually pure blockchain people. It's the users of blockchain that are donating code, and that really surprises me. You never know who your collaborators are going to be, and it's good because they guide the shape of it, right? We think that we're building a really good bicycle, and then our collaborator says, forget the bicycle, let's make this into a motorcycle or something, right? So it's
and IBM's making these services available in the cloud.
Yeah.
And then you talked about some level of security, EAC5 and FIPS, and threw out a couple of other nomenclatures that I wasn't familiar with. But you made a statement that it's the most secure that you're aware of. Can you share with us what you've done there? And
Yeah.
Why
So,
it's so important?
there's something called FIPS 142 Level 4, Federal Information Processing Standard 140-2 Level 4, right? So it's a set of guidelines for any software or hardware manufacturer providing cryptographic algorithms. It has this behavior. It has to protect your data in such a way to be qualified for FIPS 140 Level 2. Your crypto algorithms have to pass, these set of criteria. There's 4 levels of FIPS 142. Level 1 is the weakest, and level 4 is the strongest. The existing computer systems out there that provide crypto algorithms, you'll find levels 1 and 2. If the industry really requires it, you'll have specialized companies provide these hardware modules that you could network attach that gives you the level 3. And IBM Z Systems, the Linux One server is the only one that has the strongest level 4. And in fact, it's not something that's network attached so that it could be hackable by network intruders. It's built into the system. The reason why we had to qualify for FIPS 140-2 level 4 is because if you're providing crypto algorithms for any type of regulated industry, financial, healthcare, insurance, many governments require that level of certification. So we had to do it for all these others, for all the sensitive data, and then we said, people are putting this type of data on the blockchain. Let's make sure that this vault we built also protects blockchain.
So given the inherent security attributes of blockchain, there are obviously security applications and use cases. I know IBM's working on some, MIT's got Enigma. Can you share with us kind of what you think the potential is for blockchain as a new security paradigm?
Now that's very interesting, right? So that will be really interesting. Like 2 years from now, we come back and we see if this takes hold, right? At the heart of all these endeavors is this idea of what is identity, right? So, I trust that you're Dave, right? And you trust that I'm Donna, right? We see each other, right? But what if we weren't sitting physically across from each other? What if we couldn't even Skype each other? How would you ensure that this other person that you couldn't even see is Donna, right? And then, so you have like crude levels of like authentication, user ID, passwords, those are hackable, right? Then, the things coming up in the industry now is multi-factor authentication, not just one password, but okay, hey, we'll send you send something to your cell phone and only you as the owner of the cell phone could see it, we'll send it to your email system, right? But it's all to try to prove that you are who you are, right? And blockchain, since it is once you put a record on the blockchain, you can't change it. There's a set of documents, right, that people, governments, corporations are coalescing around. That if you have, for example, this driver's license, you have this in the USA, this social security number, you have this passport number, right? Maybe if you have these 3 types of identification, then we really know that you are, you're Dave. In other countries, they might say, okay, you also have to supply like your last 3 postal addresses or something. But the answers to those questions, I mean, we do it every time we sign up for a website. We have to put like 5 to 10 personal questions, right? I mean, that is so inefficient, right? But if that information could be on a blockchain somewhere, secured and protected, right? And then you provide something called zero knowledge proof, where, all right, I'm Donna, and I've provided 2 out of the 5 criteria, right? And when that blockchain identification service says, okay, Donna answered these questions, Dave, you could really believe this is Donna without Dave ever having to know what are the answers to my personal questions, right? That is the substance of this collaboration. It is, how do you prove who you are and not have to answer the same questions like 100 times over?
The black box validates it, and I then, as a consequence, trust that you are Donna. So okay, good.
That's very interesting, right?
Yeah, and you think that's a couple years we'll start to see commercial use cases for that type of technology?
Imagine that. Imagine how smaller your wallet's going to be, right? No more driver's license, no more social security card, no more like whatever card, right? I mean, Boy,
Awesome.
that's really good. Yeah.
Well, Donna, it's great to see you face to face,
Okay.
and I really appreciate your time. Thanks for coming on theCUBE.
All right, thank you.
All right, keep it
Hey.
right there, everybody. Stu and I will be back with our next guest. This is theCUBE, we're live from IBM Edge, hashtag IBM Edge.